Welcome back to the next part in our series on the applications of integration. In this particular video, we're moving on to look at mixed areas. And that's where we have a function who has part of the area being above the x-axis and part of the area being below the x-axis. And in the previous videos, we looked at areas above and areas below the x-axis. And one really important thing was that for any area that's below the x-axis, you have to take that into consideration when you're doing your calculation. And we discussed two methods, and you can use the addition of a negative sign out the front of your integral. So that's the one we're actually going to show in this particular video. Or in the previous video, we looked at how we could swap the terminals to make the integral value positive, because we know that areas are positive values. So for this one, we're going to calculate the area that is between 0 and 3 pi on 2 for 2 sine of x. So if I go ahead and shade that region, that's the region there that we are trying to find the area of. So to calculate that area, I'll just come over here because we'll need plenty of room. We have that area is going to equal, and first of all we do the integral between 0 and pi, and that's the area that's above the x-axis, so we just do that directly. So we go from 0 to pi of 2 sine of x dx, and then instead of adding on the next area, because it's below the x-axis, we're going to subtract away that area. So that's the add the negative sign out the front. So we have negative the integral between pi and 3 pi on 2. So we have pi as our lower terminal, and we have 3 pi over 2 as our upper terminal there. And we still have the functions rule 2 sine of x dx. So next, our job is just to evaluate this. So first of all, we can just find the antiderivative. So 2 sine of x will actually become minus 2 cos of x. And for the first one, we're going to evaluate that between 0 and pi. And then we're going to subtract away the antiderivative evaluated between the values of pi and 3 pi on 2. So to evaluate these, we're going to substitute in, for this first one, the upper terminal of pi. So we're going to have minus 2 cos of pi. And we're going to subtract away minus 2 times cos of 0. And then we're going to subtract away from that. And for this, we're going to have minus 2 times cos of the upper terminal, which is 3 pi on 2. And then we subtract negative 2 cos of the lower terminal of simply pi substituted in. So now we just need to clean this up using our knowledge of exact values. So this will give us in the first bracket minus 2 times, and cos of pi is minus 1. And then minus 2 gives positive 2 times cos of 0, and cos of 0 is positive 1. And then we're going to subtract away from that, and we have minus 2 times cos of 3 pi on 2, which has an exact value of 0. And then we have subtract negative 2, which will become positive 2 times, and cos of pi, which is negative 1. And then this is very close to our final answer. So here we have minus 2 times negative 1, which is positive 2, plus, and that's also positive 2. And then we subtract away from that. This is negative 2 times 0, so that's just 0. And then we have a minus 2 here. So the minus 2 becomes plus 2. And 2 plus 2 plus 2 is equal to 6. So the area is 6 units squared. So that's the total area that's shaded in the diagram just above. So once again, I do hope that this video has helped. Make sure you stick around for the next video where we're going to look at another application, which is going to be the average value of a function. And as always, you can check out the description below, which will have links to other videos like this on integration. So I hope this has helped, and make sure you stay around for the next video.